don't think it'll be full capacity, but they'll have people there.
Yeah, I mean, most of the colleges are lining up that fans.
Yeah.
It seems like the SEC schools let more in.
Yeah, they stormed the field after the Notre Dame Clemson game. I was like,
I just looked like, yeah, it looked like a COVID mass, you know, it's like they're showing all the cities, you know, and I'm like, they're celebrating, and
I
I'm
was
just
like,
like,
you might as well have.
well, I hope that New York City Times Square right now looks like a COVID masterpiece down there, but I remember all the protests this summer, and that didn't seem to spark anything.
Yeah.
But gatherings, all the Thanksgiving and Christmas, that's.
The football schedule's set, right?
Yeah, I think so. I think it starts early February.
I'm so used to like filling my board up before students come to class, but I realize like nobody in the grid actually can see what I'm writing, so it doesn't pay to. So do you guys have a midnight Christmas service at the church
Mm-hmm.
that lasts like hours and hours and hours?
Yeah, it's more a lot for Easter though.
That's true, and then you eat afterwards, a
Yep,
big meal at the.
I really gamed the system this year though for Easter because of COVID. We were like, well, where are we gonna eat? You know, cause normally we just eat at church and they bake like a whole lamb. But this year I was like, I really wanna break my 40-day fast with no meat with Chick-fil-A. But I could only eat on a Sunday, so I went to Chick-fil-A Saturday night at like 9:58 and like ordered a ton of chicken, and so that way we broke our fast in our kitchen with our like little candles eating Chick-fil-A on Sunday. It was the best.
At midnight, that's funny, yeah, unless somebody's been to an Orthodox service, they really have no idea.
Yeah.
And then it's in Greek, and you're just like, you've got to be kidding.
Well, it's not that bad when you understand it.
I guess that's
Yeah.
true, I guess that's true. But when you don't understand it at all,
Yeah.
it's like, and then everybody knows what they're doing except you, and you're just trying to follow along and pretend like you know what you're doing.
Are you gonna go to church this year? Do you even have a church that's open to go to?
Yeah, we're not, I mean, there is an Orthodox church in town, but it's really small.
Yeah.
So yeah, I don't know what they're gonna do this year. I don't know.
Yeah,
That's-
because my grandparents are coming, we're just gonna watch it on TV
See,
instead
that's
of going
nice.
in, cause we're too worried about them
Yeah,
getting
right.
something.
That's what we were talking about. It's just so dangerous for older people.
Mhm.
We have what next week? I mean, this Friday.
A quest.
Our quest, yeah, last quest before break.
Once we go home, how long are we like still in school for? Is it like
2 weeks after break. That's pretty much what it is.
But do you know when our final's gonna be?
It'll be probably on final day, but it'll be a quest, not a final,
Right.
so. But yeah, I don't know, I'll see. If somebody wants to take it, if you guys wanna take it early, I might. I don't know, we'll see. I know some professors are like shutting down everything at Thanksgiving break. I'm just like, that's bull crap. You know, that's- you're already on teaching. It's just gonna be, the thing that's gonna be hard for me is like, I'm used to having you guys in class now. And then it's gonna be back to the grid. I'm gonna be back there just teaching the screen and not teaching human beings. And I just feel like it's so much of my class, it's about building relationships. And it's been hard because it's just broken. When we're together 3 days a week, we can really build rapport. And then, like when you're in groups, I can like get around and be there, learn your names and things like that. But this has just been such a bizarre semester. Normally I know all my students' names. It takes me forever because I'm dumb. But by the time I learn them, you know, I know them for like the rest of their lives. I can see them across a field and, you know, I'll just know them 15 years later at homecoming.
Dr. Warren, you should just have us wear like name exercises.
Well, it's easy when you're on the grid. You know,
Yeah.
like, oh, there's Steve, there's Colin, there's Lindsay, and then if I look hard, I can see Aiden. Aiden I saw at Home Depot live. I saw him at Home Depot live. Yeah, that's, looked enthralling, Aiden, looked enthralling there. That's,
Oh, yeah.
they got you behind the desk. They must know you're smart.
No, I literally just like browse Twitter most of the time.
That's. Mason, how are you doing, Mason?
I'm really tired, but other than that, I'm fine.
Yeah, I'm tired too. I'm tired too.
I got like an hour and a half of sleep last night.
Oh, ouch. Did you have a big test today? Or were you partying, Mason?
We're working on a project.
Oh, working on a project. Okay. That's- Lainey, how are you?
We're thriving.
Thriving. No. Yeah, okay. All right. Okay, why don't we stand up? Why don't we stand up and get ourselves thriving here? Let's at least get ourselves turned on. Okay, so let's turn on our brains. Okay, sit back down, sit back down. We have what this Friday? Quest number 4. Quest number 4. Okay, there will be no WebAssign due this week. There'll be no WebAssign. Everything that we do today in class, everything that we talk about today is fair game. Okay? But it'll primarily be related to the recent stuff we've been doing, increasing, decreasing, critical points, concave up, concave down, local maxes, local mins, global maxes, global mins. Are you guys all beginning to feel reasonably comfortable with those kinds of things and those kinds of problems? Okay, so the local maxes, increasing, decreasing, critical points are all related to what derivative? First derivative. Concave up, concave down, inflection points, that's all related to second derivative. Okay, today we start something new. Today we start a brand new chapter. If we get time at the end, I'm going to go back and pick up one more section in chapter 4. But today we're starting chapter 5, and I'm going to need you guys to refresh me a little bit on some derivative ideas. The derivative of x to the 7th. How many people think they can do that? The derivative of x to the 7th. Let's start off easy. Especially for Mason, since he only got an hour and a half. So Mason, what's the derivative of x to the 7th?
7x to the 6th.
Very good. 7x to the 6th. Now let's imagine that x is pregnant. The x is pregnant. The x to the 7th. And now it's not just x to the 7th, but it's f of x to the 7th. Using our power chain rule, what's the derivative of that? 7 times f of x to the
6 times f prime of x.
times f prime of x. There's the chain reaction part. How many people know that? How many people know that? Okay, now here's something we haven't talked about in a little while, probably since Algebra 2, because I don't think you would have used this in pre-calc. What does a exclamation point. And let me tell you, it's not 8. Does that make sense? Does it make sense?
Yeah.
In math, it's not 8. What does 8 exclamation point mean in mathematics? 8 factorial. And that means 1 times, 2 times,
3 times.
or up to,
8.
okay, we'll do 7 times 8. And then, typically though, we probably write it the other way, 8 times 7 times 6, 3 times 2 times 1. So for example, 15 factorial. 15, what does that equal? What does that equal?
15 times 14 times 13 times 3 times 2 times 1.
Yeah, we're not doing that, Dr. Warren, we're like that. Now this is the rule, this is the thing we're gonna need. If I've got 8 divided by 8 factorial, well that means 8 divided by
8 times 7 times 6 times 3 times 2 times 1.
But I want you to see something that's pretty neat with factorial. If you've got 8 over 8 factorial, because it's multiplication, this guy kills that guy. And so you're left with 1 over 7 times 6 times 5. But 7 times 6 times 5 all the way down to 1 is the same thing as 7 factorial. So could you guess what 15 over 15 factorial is? Could you guess what 15 over 15 factorial? What do you think that would be?
1 over 14 factorial.
1 over 14 factorial. 9 over 9 factorial would be 1 over 8 factorial. How many people are getting this? How many people are getting this? Okay, we're now ready to define, and probably for the first time for you guys, a function that's driven you insane for a good part of biology, chemistry, pre-calculus, and algebra 2. It's this function, I'll call it g of x. And it's equal to e to the x. How many people have seen e to the x before? It's an exponential function. It's an exponential function. It's like 2 to the x. I gotta ask, is 2 to the x a pretty powerful function? Did we figure that out last time? 2 to the x is a, remember the game we can play with mom and dad? Guys, don't do that to your parents, okay? Don't go, stealing a couple million from them, all right, on that last day. 2 to the x is a really powerful function, but e is approximately equal to 2.71, and it's an irrational number, it goes on, and so you're really talking about this function to the x. But you've never had the exponential function defined for you, and that's what I'm going to define for you now. It's defined in terms of a infinite polynomial. What did I say?
Infinite polynomial.
Oh, hell. What did you say, Dr. Warren? Infinite polynomial. And I'm going to give you this polynomial and you're not going to like it. But it's okay. We don't have to deal with the polynomial that much. It starts with the number 1. That's the constant part of the polynomial. And the next term is x. The next term is x. So it's linear, like a line, it looks like 1 plus x. But I said it's a what kind of polynomial?
Infinite.
So it has infinitely many terms. The next term is 1 over 2 factorial, which just means 2 times 1, times x squared.
What?
The next term is 1 over 3 factorial times x cubed. The next term, can you guess what the next, could you guys guess what the next term, could you guess what the next term might be?
1 over 4
1 over 4 factorial times
x to the 4.
x to the 4th. And then it just keeps going on and on and on forever and ever and ever and ever and ever. Now, I want you guys, if you have a calculator, take it out. Or if you have a phone, take it out. If you have a calculator, take it out. Or if you have a phone, take it out. Okay, does your calculator, your phone, can you do exponential stuff on your calculator? Can you do exponential stuff on your calculator? So could somebody give me what the calculator has for, let's just say, e raised to the 2? Could somebody give me what the calculator gives you? And I want the decimal places too. Give me what e to the 2 is.
7.389. Do you want me to keep going?
7.38, 9,
905.
and then it just keeps going on like that and that, like that. Okay, now I want to go up here, and wherever I see the x, I'm going to put a 2. Wherever I see the x, I'm going to put a 2. So e to the 2, with this formula, would be 1 plus 2 plus, now you guys help me out. What is 2 times 1? What is 2 times 1? 2. So that's that. And what is 2 squared? What is 2 squared? 4. Now you guys help me out. Calculate 3 factorial in your head. I can't do that, Dr. 1. Yes, you can. 3 times 2 times 1. What is that?
1/6.
Now this gets a little harder. What is 2 cubed? What is 2 cubed? 8. Then can you do 4 factorial? No, I cannot, Dr. 1. 24. And then what is 2 to the 4? 16. And then we'll just stop with this next one. We'll just stop with this one. I know this is going to be a little bit harder. 5 factorial. 5 times 4 times 3 times 2 times 120. And then I'll do this over 32. So let's just stop there. Let's just stop there. So let's take our calculator and you guys can help me out. We can do the first ones by hand. 1 plus 2 is?
3.
4 times 1/2 is?
2.
So we had 3, we added 2 more. So if I just look at from there to there, I've got a 5. Then I've got 8 over 6. But that's the same thing as 4 over 3. And now we better grab our calculator. Let's do 5 plus 4 over 3. And what do you have? If you do 5 plus 4 over 3, what do you have? 5 plus 4 over 3, what do you have?
6.3.
6.333. So here, we're up to 6.333. Now we've got 16 over 24, but that's the same thing as 16 over 24 is the same thing as 16 over 24 is the same thing as, I know this is hard, 2/3. So that would be like if we added 2/3 onto this, but 2/3 is like 0.66666666. It's a scary number. Okay, 2/3, 0.666666. Okay, 2/3 plus, that would be 7. So if we're just to this point, we're at 7. Now you're going to need your calculator. Do 32 divided by 120. Do 32 divided by 120. And what is that number? What is 32 divided by 120? 0.2666. So if I added that onto my 7, I'd be at 7.266 like this. Do you see how we're getting closer to this number? And if we kept, now there's infinitely many terms. You know what you guys don't understand is that you grab your phones and you grab your calculators and you somehow think, I mean, you look at this, how many people can't drive without Google Maps? Like if you go somewhere new, you can't drive without Google Maps. You've got to have something, Waze. I don't even know what a Waze is. Okay, but you guys don't think this thing is dumb. This thing is dumb. It basically does this. Now it's a little harder for you guys at home, because that just shows nothing. Off, on, off. What did you do learning calculus today? Off, off, off.
On.
Guys, everything that this phone does is off on. That's the way computers work. They're off or they're on. It just so happens they do off on really, really, really quickly and with lots of circuits. You think of this as being really smart, but it's not. Probably the most intelligent thing it has is this thing called the arithmetic logic unit. Say that. They call it the ALU. That's kind of like in the CPU, the central processing unit. In that core is this thing called the arithmetic logic unit, and it does addition. That's what it does. It does subtraction with addition. It does multiplication with, it does division with addition. And it is essentially just off on. It's really fun to code up a computer just with wires and just with light bulbs and see the gates. How do you think how many people have used the calculator before to do e raised to some power? But for you guys, it's like it's coming from heaven. And it's like, it's the same thing. How did the calculator do that? Well, it's magic, Dr. Warren. It's called calculator magic. All you do is you put the number in, and magically all these digits show up to the screen. You don't think, wait, how does it actually do it? Oh, it does this. It does this. Notice. Is this addition? Is this addition? Is it multiplication? Is it multiplication? That's all it is. This is the way, it's a little harder than this, but this is the way the calculator calculates e to the x. You're like, well, Dr. Warren, I'm not so happy with this right now, huh? Oh, all my erasers are here. Stand up, stand up, stand up, stand up. At home, you better be standing too. Stretch. Aiden, are you standing?
Yeah, I am.
Okay. Sit back down. Okay, I'm in danger land. I don't have my mask on. But you guys can see my face. Nick, I'm looking right at you right now. Nick, I've got you in my eye. Nick, as miserable as this function is to calculate, look at Thomas, man. He's in the game. He's in the game with me. He's leaning in. As miserable as it is, this function is an amazing function. And let me show you the reason why. If I wanted to take the derivative of e to the x, if I take the derivative of e to the x, you guys help me out. It'd be like g prime of x, which is like taking the derivative of e to the x. Now you guys help me out. What's the derivative of this guy? You guys should know. 0.
1.
What's the derivative of this guy? 1. Now let's see this. We got 1 over 2 factorial. Now, we'll just ignore this guy for now. How many people can take the derivative of x squared? How many people can take the derivative? What's the derivative of x squared?
2x.
Dr. Warren, we're good. How about this? 1 over 3 factorial, we'll deal with that guy later, times 3x squared.
1 over 4 factorial.
Yeah, Miles is almost asleep. 1 over, sorry Miles, I didn't bring you back. 1 over 4 factorial times 4x cubed plus, Dr. Warren, this is so boring. 1 over 5 factorial times
5x.
then plus 1 over 6 factorial times 6x to the 6th. And then this keeps, oh, thank you. And this keeps going on forever and ever. How many people are with me so far? How many people are with me? Like, Dr. Warren, okay, I'm following so far. But what do we know about 8 over 8 factorial? What do we know about 8 over 8 factorial?
It's 1 over 7.
1 over 7 factorial. So how about if I had 3 over 3 factorial? What would that be the same thing as? Okay, 4 over 4 factorial. 1 over 3 factorial. 5 over 5 factorial, 6 over 6 factorial, 1 over 5 factorial. So let's just say this derivative is equal to 1 plus, now 2 over 2 factorial is the same thing as the other way, Jay, go down. So the 1 over 1 factorial, and 1 factorial is just 1, so 1 over 1 is just 1, so this is just the same thing as x. Then plus 3 over 3 factorial is the same thing as 1 over 2 factorial, this is when I'm hating the fact I don't have a bigger board, times x squared. That's that term. Now you guys help me out. What will this term become? What will this term become?
1 over 3.
Now, I know at home you're never going to be able to read that. That's 1 over 3 factorial, not 31. That's a 3 factorial times x to the third. I didn't plan this out real well. Plus 1 over 4 factorial times x to the fourth. And then we got our last term, which is 1 over 5 factorial. Sorry guys, but this is so small. Times x to the fifth. And this keeps going on forever and ever. So let me read this for the guys at home. This became the 1. This became an x. This is a 1 over 2 factorial x squared. This is a 1 over 3 factorial x cubed. This is a 1 over 4 factorial x to the fourth. This is a 1 over 5 factorial x to the fifth. And this just keeps going on forever and ever and ever. How many of you are following so far? I mean, I'm like, I kind of, and you guys at home, I don't know if you're really following or not because you can't see anything. So the derivative of e to the x, the derivative of the x is 1 plus x plus 1 over 2 factorial x squared, and we just keep going on forever and ever.
Which is just what e to the x.
But you're like, wait, Dr. Warren, Dr. Warren. E to the x itself is 1 x, and I'm getting chill bumps, I know you aren't. It's the geek bumps, okay? And then I'm getting a 1 over 2 factorial x squared, 1 over 3 factorial x cubed, 1 over 4 factorial x to the fourth, 1 over 5 factorial x to the fifth, and this keeps going on forever and ever. Dr. Warren, the derivative of e to the x is e to the x. The derivative of e to the x is e to the x. You mean to tell me that the derivative of this function that I hate is just itself? That's even easier than the derivative of x squared. What's the derivative of x squared? You at least have to remember something. What's the derivative of e to the x? E to the x. You don't even have to think. You could be in a car wreck. What's your name? I don't know. What's your e to the x? What'd you say? E to the x? Oh, you're right. You're right. You got it right. You're fine. You're fine. Isn't that amazing? I mean, this function that is so complicated, to evaluate it at any value, it's an irrational number, has the simplest derivative of all the functions. Has the simplest derivative of all the functions. I think that better be a flashcard. I think that better be a flashcard. Okay, so now let's see what you guys can do with this. Let's see what you do. Suppose you have the derivative of this function. Hold on. Wait a second. Suppose you have the derivative of x to the 7th divided by e to the x. Can you take the derivative of that using your flashcards? Can you take the derivative of that using quotient rule? Go ahead, take the derivative of that. You guys at your seats in the grid, take the derivative of that using our new flashcard that the derivative of e to the x is e to the x. Yes, it's x to the 7th. It's x to the 7th, Aiden. It's x to the 7th over e to the x. Okay, let's see how you did. Let's see how you did. How many people would like this to be on the next quest? How many people would like that to be on the next quest? And if you don't know, then you're like, okay, you will. How many people remember quotient rule? What's the derivative of f over g? What's the derivative of f over g? Flashcard. What's the derivative of f over g? It's the f prime times g of x minus f of x times g prime of x, all divided by g of x squared. So you guys help me out. Who's in the f location and who's in the g location?
X to the 7th.
X to the 7? Do you guys know how to take the derivative of that puppy?
Yeah.
And how about who's in the derivative of e to the x? I mean, who's in the g location? Yeah, don't listen to me at all. Okay. Okay. So in that rule, I mean, the first thing I'm going to do is I'm not going to think. Who goes in the bottom square? Who gets in the bottom square? So I just got e to the x, and I got a square there. Now you guys help me out. What's the derivative of the numerator? Times minus x to the 7 times the derivative of e to the x. But what's the derivative of e to the x? And am I done? Am I done? You could simplify a little bit by factoring in e to the x and canceling out one there, but you wouldn't have to. How many people are following? How many people are following with that? As complicated as that function is, it has such an easy derivative. Now I want to show you the graph. This is the graph of 2 to the x. This is the graph of 2 to the x. It goes like this. It's always above the x-axis. It's always above the x-axis, and it just keeps going up. Here's the graph of 3 to the x. It does the same thing. It does the same thing. It goes lays a little bit lower here. It goes through, this is 1. It goes through 1, and then it keeps going up faster. Now, e to the x is like 2.71 ... to the x. So it goes between these two. It goes between these two. It goes in between. This is e to the x. Now, one thing we notice about e to the x is that it's never negative. Do you see that? Because 2 to the x and 3 to the x are never negative. E to the x is also never negative. Say that. Write that down. In fact, e to the x is never 0. So write down e to the x is always positive. E to the x is always positive. It's always greater than 0. Okay, stand up, stand up, stand up, stand up, stand up, stand up, stand up. If you're in the room, face somebody, face somebody. If you're in the room, face somebody. Don't breathe too hard. Say, e to the x is always positive.
E to the x is always positive.
You guys are on the grid. Put your hands on the space bar, hands on the space bar, hands on the space. Tell me, look at me, say what I just told you to say. And say, damn it, it's always positive.
Damn it, it's always positive.
Okay, let's sit back down. Let's see if we can use this. Suppose I've got this function. I've got this function which is f of x equals
X squared linear.
times e to the x. And I want to ask you this. Find out when it's increasing and decreasing. And you're like,
Damn it, Dr. Warren.
that's right. I mean, come on, Harris, say that to the camera.
Damn it, Dr. Warren.
Okay, sit back down, okay? Guys, which derivative talks about increasing and decreasing? Which derivative talks about increasing and decreasing? Okay, you should know. You have a quest coming up. So take the derivative of that. Take the derivative of that. What rule do you need to start this puppy with? Product rule. Product rule. I'd so love to get closer than 6 feet so I can actually see what my students are doing. What you mean? Perfect. Yeah. Now who's the F? Okay, so yeah, and who's the G? There you go. There you go. Okay, how many people are done? How many people are done? How many people are done? Okay, so you guys help me out. What would it be? You guys help me out. Using product rule would be 2x times e to the x plus that crazy plus in product rule, x squared times, and then Paris was up here going, damn it, Dr. Warren. And you're like, okay. Well, what's the next step? I mean, when you're finding intervals of increase and decrease, what's the next step?
Here we go, just kidding.
Critical points, yeah, it's a factor, right? I mean, let's set this derivative equal to 0. Let's set this derivative equal to 0. So 2x e to the x plus x squared e to the x. And we're looking for when it's equal to 0. What's the next move in this game? What's the next move in the game, guys? Factor. What can you factor? What can you factor out of? What can you factor out of each of these? You can factor an x and a e to the x. Now you guys are gonna have to do this right. You're gonna have to help Dr. Warren to do it right. If you factor an x e to the x out of this, what will you have left?
2.
And then what will you have left here? Okay. You guys got up and just said what to each other? E to the x is always positive. So can e to the x ever make this 0? No. But could x make it 0?
Yes.
So that's going to be one of your critical points. So I know my derivative is 0 at 0. Is there another critical point? Is there another value of x that would make your derivative 0? Negative 2. So I know I have critical points at 0 and negative 2. But more importantly than there's 0 there is that they are the only zeros. So now all I've got to do is test. Give me a number that's bigger than 0. 1. Okay, so you guys can help me out. Let's use the factored form. Positive or negative? Positive or negative? Positive or negative? Always positive. 2 plus 1, positive or negative? Positive times a positive times a positive is going to be a positive. A number between 0 and negative 2. Negative 1. So again, I'm coming here. Let's look at the x. I put a negative 1 in. Positive or negative? E to the negative 1. Always positive. We yelled at each other. 2 plus negative 1. Positive or negative? So I've got a negative times a positive, which would be a negative. I know I'm negative in here. You're running out of time on the quest. You're running out of time. You're panicked. What do you make a guess that would be over there? Yeah, I mean, most of the time that'll work for you. Most of the time. Occasionally it won't. We're not running out of time, so give me a number less than negative 2. Negative 3, so you guys are going to help me. If I put a -3 in there, positive or negative? I put a -3 in here, positive or negative? I put a -3 in here, positive or negative? Negative times a positive times a negative is a positive, so it did work. Which means it's the first derivative, this means I'm increasing, then I'm, and then I'm increasing. So if they ask for intervals of decrease, it would be between, intervals of decrease would be between -2 and 0. Are there any local maxes? Are there places where we go up and go down?
Yeah.
So f of -2 would be a local, f of -2 would be a local, f of 0 would be a local min. Does this make sense? Does this make sense? So as scary as e to the x looks, in calculus, e to the x ain't that bad. In fact, it's one of the easiest functions to deal with. And guys, you're gonna go home for Thanksgiving. How many people are like, wait, I mean, you're not coming back? How many people are like going to go home for Thanksgiving and not come back after that? Okay, like if you show your parents this, they'll be really impressed. They'll be like, whoa, look at what my kid can do. This is increasing and decreasing. You don't have to tell them, oh yeah, it's the easiest function ever. The derivative of the x is, the derivative of the x is, e to the x. It's so simple. The derivative of the x is e to the x. And e to the x is always what we stand up and swear at each other. Positive. Is that useful? Is that useful?
Yes.
Okay. Stand up again. Stand up again. Look at somebody and say, you're not going to understand this.
You're not.
You're not problem.
Rest in peace.
Aiden, it looks like you're, no, okay, never mind. I thought you were in a, Thomas, it looks like you're in a cathedral, but you're not, are you?
No, I'm just in a really nice room.
A really nice room, that's nice, okay. Okay, let's sit back down, let's sit back down.
I think those are just like curtains.
Oh, maybe they are curtains, yeah. Jonathan, how are you doing, man?
Doing great, how are you?
Good. Jonathan Very, how are you doing?
Doing good.
Doing good? Nick, how are you today?
Yeah.
We should ask Aiden how that alien is doing. He's wearing a mask.
Aiden, somebody has a request.
What's that?
They want to know how your alien's doing.
He's doing pretty good.
Is he wearing a mask?
What's that?
Is he wearing a mask?
Yes, he is.
Look at that, socially responsible aliens, okay, okay,
If
okay.
they can do it, so can we.
Yes, if they, so one would think, okay, oh, let's see if you learned anything today. Dr. Warren, let's just say I'm tired. Do not look at your notes. Do not look at your notes. Do not look at your
Notes.
Okay. How did we define e to the x? Write down what we defined it to be. Do not look at your notes.
My notes.
I'll give you a hint. It's an infinite polynomial. It's an infinite polynomial. Can you write down what that infinite polynomial is? Or would you be destroyed on a true-false question on the quest? Okay, I'm picking on Lorelei.
Uh-oh.
Lorelei, how does it start?
1
1, very good.
plus x
Plus x.
plus 1 over 2 factorial times x squared
Perfect.
plus 1 over 3 factorial x cubed times x cubed. Oh yeah, sorry, factorial. Plus 1 over 4 factorial x to the 4th.
And we'll just stop there and go dot, dot, dot like that.
Thank you.
Thank you. How many people are with me? How many people got that? Okay, now, we're not going to do this very often, but let's imagine that I said, what's e to the 3? Imagine I said, what's e to the 3? Then wherever I see a, I would put a 3. How many people could do that? How many people, let's pretend we did and not. What if I said e to the beer over 2 factorial,
Beer can squared.
1 over 3 factorial,
Beer can cubed.
1 over 4 factorial.
Beer can four.
Okay, now you're really not going to like the next thing we're gonna do. What if I said e to the f of x? Well, who's the beer can? Who's the beer can? Okay, so write it down, write it down. You guys try to write down what that would be equal to. Just use those 4 terms in the polynomial. Now, for sake of time, guys, for sake of time, just look at the board and see if you got the same thing. How many people started with a 1? How many people started with a 1? And then how many people had the f of x in that location? And then did you have an f of x squared and so on and so on and so on? How many people are following so far? How many people are following so far? Okay, so now I've got to ask this. I've got to ask this. If you have a term like 1 over 7 factorial, f of x to the 7. If I have a term like that, what is this? Read it, guys, in the grid. Can you guys read that? What does that say?
1 over 7 factorial.
And then f of x to the 7. Imagine I took this derivative. Imagine I take the derivative. 1 over 7 factorial is just a, 1 over 7 factorial is just a constant. So it comes out. It's just a constant. Now, can you guys take the derivative of f of x to the 7th? You did it a little earlier today. What's the derivative of f of x to the 7th? 7 f of x to the 6th. But what are you forgetting?
F prime.
Chain rule f prime of x. How many people are following? How many people are following? But what is 7 over 7 factorial? What is 7 over 7 factorial equal to? 1 over 6 factorial. So this term's derivative would be the same thing as 1 over 6 factorial f of x to the 6th times f prime of x. Are you guys following? I mean, this is a little more challenging. Okay, now here comes the nightmare. You guys are going to do this with me. We're going to do it together. Okay, that's a lie. I'm going to do it. I'm going to do it. I'm going to take the derivative of e to the f of x. Everybody's got the first term. Like that's one we own you. We're with you. What derivative of 1? 0. Now we're done, Dr. Warren. We're not doing anything else. I don't have anything better than to write f prime of x, so I'll do that, f prime of x. But now, notice the remaining terms. The remaining terms are in the exact same form as this. The remaining terms, all the remaining terms, and the rest of the polynomial are in the same form as 1 over 7 factorial f of x to the 7th. But that derivative ended up being... No, let's try that again. I'm always amazed when I speak total gibberish, how people like are more alert. You know, it's like I speak English after a while and people, almost like it's a drug rehab in the room. You know, you look around, I look around the room and I look at the eyes and they're like, I'm like, okay, we got issues in class. And then I like go, okay. What's he saying? I deliver good from go on. What?
Boom! Whoa! So you can look up with them? The women walk like the wall. Like a wall. Like a wall. Like a wall. Well, it's not working. English, I need to use English. See, what if I took the derivative of 1 over 4 factorial times f of x to the 4th? What do you think that derivative would be? Using that same kind of analysis, what do you think the derivative of this term would be? 1 over 3 factorial f of x to the 3rd times an f prime of x. Times an f. Does that make sense? Does that make sense?
Yeah.
Now how about this one? If I took the derivative of this one, what would I have? F of x squared times f prime of x. Now this term that we have left here, which is, we had 0 and then f prime of x, this term would be 1 over 1 factorial, which is just 1 factorial. F of x to the 1 times f prime of x. So even though it was complicated, taking the derivative wasn't that bad. How many people are following? Okay. What's alike in every single one of these terms? Just look at every single term that's not 0. What's alike in every single one of those terms? Just look up there. What's alike in every single one of the terms? Do you guys see there's an f prime of x? Do you see there's an f prime of x literally in every single term? There's infinitely many terms, but every single one of them has a f prime of x. So let's factor that out. No, Dr. Warren, let's not say we did. So I'm just going to pull it out front. I'm pulling an f prime of x out of all the terms, every single one. What would I have left there? What would I have left there, guys, if I pulled it out? 1.
Plus f of x.
Now what would I get here? F of x. Now what would I have left here, guys, if I pulled that out? What would I have left there?
1 over 2 factorial.
1 over 2 factorial times
F of x squared.
f of x squared. And then how about the next one? What would I have in the next one?
1 over 3 factorial.
1 over 3 factorial times f of x cubed. Now I know there isn't the next term, but if you had to guess what the next term would be, what do you think? We didn't do it, but what would you guess the next term would be?
1 over
F of x to the, and I know we didn't do the next term, but if you had to do the next term, what do you think it would be? F of x to the 5th, and now I'm running out of back. And this keeps going on forever and ever and ever and ever. Now I gotta ask for the 5th time, how many people are following me? How many people are following me? Kind of. What's alike in each one of these terms? What was alike in each one of those terms because of the chain rule that we were doing? F prime of x. What did we do with that f prime of x? Factored it out. We pulled it way out here. Now let's see what's left. We had a
1.
Oh, damn it, Dr. Warren. We have a ooh.
Wow.
Oh. Do they match?
Yes.
Yeah.
But all of that was this. Look at this. This is the most athletic thing I've ever done in my life, right there. Look at that. That was e to the
F of x.
Is this not the exact same sum? Is that not the exact same sum?
It is.
So that's equal to
E
e to the f of x. Wait, Dr. Warren. The derivative of e to the f of x is equal to e to the f of x times. Yes, it is. Yes, it is. Will we have to reproduce this, Dr. Warren, on the quest? No.
Oh.
No, well, Dr. Warren, I don't care anymore, I'm not writing anything down, I'm not writing anything down. But guys, we've showed today that the derivative of e to the x is e to the x, and if e is pregnant with an f of x, the derivative of e to the f of x ain't much worse. It's just e to the f of x times f prime of x. It's my exponential chain rule. You're like, Dr. Warren, it's a lot like chain rule. It's like a power chain rule. It's the derivative evaluated at f of x times f prime of x. Okay, let's finish class today. Let's finish class today by just looking at a pregnant exponential function and trying to take the derivative. So you guys are gonna help me out. Let's erase everything. This is a flashcard. What did I say?
This is the flashcard.
And you guys can be working on this at home over Thanksgiving break.
You're funny.
No, I highly recommend taking all of your work home for Thanksgiving break. Because when you're bored, you can look at your work and then you're not bored anymore. You'll be like, oh, I could be doing my calculus. Oh, I'm not bored. I thought I was bored, but now I'm not bored. Oh, I could be doing my English. No, I'm not bored anymore. I'll watch some more Netflix. So you take all your work home over a break for anti-boredom devices. Sadly, you're not coming back. After break, which is killing me, because now it's just me teaching the grid. And you look less human there, guys. I mean, you're two-dimensional to me. I know you're multi-dimensional, but I'm looking at you. How I wish there was just rooms full of people.
Dr. Warren, are you even allowed to teach if people are still back here, or is it just all across the board you're not allowed to?
I'm not allowed to teach. Yeah, I don't think I'm allowed to teach. I could test it. I'd be willing to test it. Okay, let's finish class with this. I've got an e, and it's pregnant with a, I don't know, x cubed plus 5x squared plus 7x plus 3.
Oh, my first.
X cubed plus 5x squared plus 7x plus 3. And I'm going to ask, what is the derivative of this? And you're like, you're sick. And then you remember the flashcard. Oh, the derivative of e to the f of x is equal to,
Is that 7x?
that is a
Okay,
7x.
sorry.
The derivative of e to the f of x is equal to, stop, just write this down again. Well, Dr. Warren, I could do that blind. So I'll try it blind. Not bad. For a blind man. Am I done? No. Just like with every chain rule, we have a f prime of x. But guys, can you guys take the derivative of that? Can you take the derivative of that exponent pretty easily? It would be 3x squared plus 10x plus 7. And there you're done. Like Dr. Warren, the exponential function ain't so bad. It's not so bad. Okay, we'll pick up with this on. This is the last content. That will be on the quest. Thanks, guys, for coming out there on the grid. Thanks for showing up today.
Thank you, Dr.
Thanks, guys.
Writing another one out for me? Like this one that we did?
This one that we just did?
Yeah, I didn't follow that one.
Okay, yes. Alex, I don't care. I'm sure you don't have COVID. Okay, so this is like that.
Okay.
So imagine it's like 5.
Okay,
So the 5 just comes out of the derivative.
okay.
You know, like for example,
Like this.
like if you had 5 times
Hey, Dr.
x
Warren,
squared. Oh, thanks, Jay. If you had the derivative of that, it's like, okay, we kind of ignore the 5. What's the derivative of x squared?
2x.
2x, and so that's where we get our 10x. But then we just do 5 times 2 when we're thinking about it. So if I think about the 1 over 7 factorial, it's kind of like a 5. It's more than that, it's whatever 1 over 7 factorial is. But that just comes out. That's just hanging there.
Okay.
Now you help me with the derivative of that. What's the derivative of that?
7 times x is 6.
Good, Alex. and then chain rules.
Oh, so then it'd just be 1/6 factorial.
Good, but there's also, what
But
else
the-
is,
okay.
what else are you missing on the end there?
The chain rule.
Yeah, what's on that, if you're right, it's 7 f of x to the 6,
So then you have to do, I'm not forgetting chain rule now.
the f prime of x.
You just do whatever 6 times 7 is times, f of x, and then, or to the power of 5, and then times f prime of x.
Okay, so yeah, I think you understand, but you're not saying exactly, so, you've taken the derivative of this now, you put the 7 down, subtracted 1, got the 6, then from our power chain rule, it's times f prime of x. Remember the derivative of f of x to the k is k, f of x to the k minus 1 times f prime of x.
Mhm.
So now, 7/7 factorial is the same thing as 1/6 factorial.
Yeah.
F of x to the 6 times f prime of x.
You don't take isn't this the k, so you would pull that out to here?
We did that there. You'd already done the k move there.
Oh, I already done the k.
You already done the
Okay.
k move there.
Okay.
It makes sense to, so let's just suppose we had this. Suppose I had 1/8 factorial times f of x to the
You guys
8.
can leave if you want.
What would the derivative of that be equal to?
That's a great question.
Can I still have one on the board, Dr. Warren?
Yes.
I don't remember what it was.
Coming up next.
Wait, what is it again? Alex, read it.
1/8 factorial times f of x to the 8.
Wait, times f of x to the 8th?
Yeah.
Okay.